Okay, your test will be equation of motion, work and energy. Yeah? The test one will be, question one will be equation of motion and Newton law, work, energy. Yeah? Question one, question two. We are now still stuck at kinematic of particles. Your test covered up to here, so we still have like 3 chapter to go. Huh? Yeah, 3 chapter. So, but anyway, if you understand chapter 1, it actually is a little bit add-on of what you learned in chapter 1. Chapter 1 is a bit lengthy, but the rest is just add-on. Okay. We have done the projectile question, right? Projectile question. So we have completed the rectilinear motion. You have continuous and erratic motion. So here you have 3 Newton equation plus the graph. You have 5 graph here. Okay. And this one is in straight line and is projectile. You use the 3 Newton equation. Because G equal to 9.81. It depends on the direction. Normally it will be negative G. A equal to negative G, apply in 3 Newton equation. Then we have previously, we also introduced you what is curvilinear motion. Curvilinear motion, this is curvilinear motion. Curvilinear motion, you have a curve, and all the curve has always have a center O, always pointing inside the curve. Okay. Then every curve, you no longer use X and Y. You will use tangent and normal. Okay. So if the line pointing this way, I write T here means positive direction, this direction. If the line I point here means N, positive this direction. Okay. And previously, you should know how to draw the velocity. You should know how to draw the velocity. Velocity always tangent to the curve from the center. Which is it's follow the T. Okay, this is V. V in tangent direction. Acceleration, it depends. Acceleration, you have N and T, then you find the resultant. Now we continue the curvilinear motion. So let's say you have a pathway. You have a curve here. So once it travels from O and then reach a position here, this is still a curve. So every time you solve a curve problems, you go to the position there, open your index and your thumb. You put the L there, L shape there. Means this one is the tangent direction. This is a normal direction. Every time you see a curve, the first step, you establish the T and N. That is a usual step. Okay. Then this is UT. UT is the same concept as what you learn in X, Y, Z. When X, Y, Z, unit vector is what? Unit vector is I. In Y direction is J. In Z is K. This is what you learn. This is called unit vector. So here also you have unit vector. UT is a direction, it's a unit vector also, but it's in T direction, tangent direction. Okay, so UN is normal direction. Okay, normal direction, where's the direction? Pointing to the center of the curve. Center of the curve. Okay, the rest you read. The rest you read. Important, you understand. When you're seeing a curve, what should you do? Establish axis first, T and N. Then write where is your UT and UN. This is the unit vector. Unit vector. Here. UT, this one is a unit vector, bracket, is a normal direction. Okay, it's the same lah. Okay. Okay, the rest is logic. It means if the object travel in t, this is a positive direction. This is positive direction. If you get a positive value, means it's in a t direction. This is a n direction. And you can derive the equation by looking every curve as a small circumference on the curve. Let's say this is a curve. You can assume that the thing happened in a very small, this is O, very small angle. And this one happened is in radian. When you have radian, you can use the R and S equation. S equal to R theta. Solve the equation. Okay. So this is what they mean. In this case, the R is represented by rho. The symbol of rho is just to differentiate the normal R. We just use this rho every time when you see there's a curve motion. Rho is actually a radius. Okay, every radius is different. This point different, this point different, this point different, and there's an equation for that lah. Okay, important that you know how to draw the center of the curve. This one, center here. Every line have different location of the center, including this one. This one curve here, center is over here, and not here. So that is the concept lah. It's the concept. Okay, this is a position. You already know already. Okay, what mean by planar motion? Planar motion means the action happen in a piece of paper in this plane. This plane. So it's a 2D problems. It's a 2D problems that you can use T and N. T and N. If it's a curve. When you see curve, forget about X and Y. Straight away use T and N. Okay. Velocity. Okay. Velocity in a curve, you use vector presentation. Vector have two things, magnitude and direction. So velocity, this is a vector, equal to magnitude and direction. Magnitude V, direction in T direction. In T direction. Why T direction? Because in earlier, we already know in every curve, the direction of the V will always tangent to the curve. That's why we only look at tangent direction. Yeah, this one. So be familiar in vector, vector form. Like for example, the more familiar one is your fxi plus fyj plus fzk. Now you change the force into velocity. Velocity xi plus velocity yj plus velocity zk. So velocity have scalar or magnitude of your v, and so on. It's a magnitude. This is just a reminder that now you're looking at vector in the velocity in vector form. Vector have two dimension. One is magnitude, one is direction. Okay. 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 How to find the magnitude of V? You recall in the earlier chapter, V equal to ds dt. V equal to ds dt to find the magnitude. Direction, you just follow the axis. V are the T and N. Acceleration is just now vector velocity equal to magnitude V, direction ut. Okay, direction UT. So to get acceleration in earlier definition of acceleration is dv dt. So we need to take this one to do time differential. But however, this one got two parameter here. So again, you need to apply the chain rules. So again, if you're not familiar with chain rule, go to the appendix, download the appendix A or B. Inside there got the vector products. So A equal to V dot. When you see dot means time differential in this chapter. dv dt means if you're lazy to write the dv, you just write a dot above the alphabet. So when you do chain rules, okay, let's say d u v, how you do? You log this one first, then you differentiate this one. U dv dt, then only you log second time this one, plus v du dt. This is a chain rules general equation. So now you have two things. This is u, this is v again, right? Or you can say this one dab. So you log the front one, differentiate the back one, plus you log the second one, differentiate the first one. Because here is u and v may be confusing, so you duplicate this one. dab equal to a db dt plus b dA dt. Means you have two parameters here. Then you do chain rules. Same with this one. So the first one, you log this one. That's why you get ut. You time differentiate this one, you get the first one. Then you log this one, you differentiate this one, you get v dot. That's the meaning of this time differential or chain rules. Okay. Okay. Now this particle move along this curve. So it will change velocity 1 in tangent direction to this position. U prime means second, the changes of velocity. Velocity ut and v comma t. This is first position, second position. And there's a change of angle here, d theta. D theta. Okay. Then you do the vector diagram. Un still the same. You copy, put here. You pull ut, put in the center, ut. You pull this one, put at the center there. You have three vector. So the changes of u to the new u, you complete this triangular. You will get a resultant component. Okay, this resultant component or the changes of u will be dut or du. The changes of u from here to here. So the resultant vector form will be u comma with this one. This one will equal to this vector plus this vector. Okay, this vector will equal to this one plus this one. How you know is this form? Let's say I randomly draw two vector, vector A, vector B. What is the resultant? This is C, resultant. So resultant, how you know is resultant is from start point to end point. Okay. So on the left will be start to end. In this case is C. Then right hand side vector equation is the component from start to end. It can be a combination of all vector. Right? Combination of all vector. So what does it mean? In this one, you only have two from start to end. So here you got A and B. If you have more than three vector, let's say, okay, let's say this is A, B, C, D, and this is E. E is from start to end. So you put E on the left-hand side. Right-hand side is a combination of the vector component from start to end. Okay, from the tail to arrow, tail arrow, tail arrow, tail arrow. Then here got A plus, then until D. Same with this diagram. So this diagram, from observing, this is the continuous vector. This vector, tail, head, this one is on the right-hand side of the equation. Then this is the tail to end, is the left-hand side of the equation. It's a vector writing. Okay. DUT. DUT, which lie on the infinity arc. This one. DUT. DUT is about here, right? About here. But this is a derivation. Derivation. I won't ask you this one. I won't ask you. Okay. This one you read. I won't ask you this one. Derivation. At the end, I just give you the final answer. This one you read. At the end, important is that you know that acceleration. Yeah. Acceleration. At the end, you only need to remember one equation. After all these slides, you only need to remember this equation. Okay? This equation. Where every time the question that link with curvature motion, recall this equation. A equal, you know that A in a curve, you only see two dimension, which is A T plus A N. Of course, this is magnitude, direction is UT, UN. This is magnitude, this is direction. Magnitude, direction. Means this one is T component, this is N component. You write this equation, write another one equation just to substitute the value. So what equal to AT? This one, AT equal to V dot. What is V dot? dV dt. This one, dV dt. This one directly take the velocity in tangent direction, differentiate with time. Okay. Then this one you copy, plus what is AN? AN equal to V square over rho. AN equal to V square over rho. What is rho? Rho is the radius of the curve. Rho is the radius of the curve. What velocity we use? Again, we are only focusing on tangent velocity, Vt. So in summarize, what is most important thing when you see curve question is Vt, velocity in tangent direction. Once you have that one, you can solve this question already. You see curvature motion. First step, draw the T and N component. When you see curve, you go to the point, draw the center O, then draw the axis T and N. After you draw this one, draw the direction of V. This is Vt. This is first step, second step, third step. Third step, write A equal to AT UT plus AN UN. Write another time, A equal to V dot T UT plus V squared divided by rho UN. This is magnitude. This is magnitude. This is also magnitude. Huh? Memorize this one. Okay. This slide is the summarize of 1.6 section. Okay. So this diagram costs you 1 mark. These two, 1 to 2 marks. You write this one, I'll give you 1 to 2 marks. Without solving a question, just give me the general equation, you solve already. Then, once you draw this one, at the end, you need to draw another diagram. It's called resultant diagram, or you have the AT and AN, right? You need to find the resultant acceleration. Okay, resultant, this is 90 degree. Tangent and normal, they are 90 degree. So you are seeing a right angled triangular here. Right angled triangular, remember, you still remember this right angled triangular, A and B will equal, you see C square equal to A square plus B square, or C equal to square root A square plus B square. So to find this magnitude, you square this one plus square this one, square root, by using this approach. That is the magnitude. Then angle. You know magnitude and you need to answer angle. This is theta. Cos, tangent, sine, or cos. Usually we use tangent. Tangent equal to B divided by A. In this case, the angle is over here. Tangent is over here. So tangent equal to this vector. You can pull this one over here. So this one divided by this one. You get this angle. Right? So you need to tell at the end the angle is from the tangent. How many degree from the tangent axis? Angle must from somewhere. You must answer the angle must from somewhere. In this case, you're referring to tangent. Sometimes the question asks you from the normal axis, this one. So once you find this angle, take 90 degree minus this one, you get this one. Okay, just to summarize, what is important is these slides. Write A equal to E dot UT plus square V square over rho UN. This one is AT, this one is AN. Remember that one. I won't ask you on the derivation steps. I will ask you on the application of this equation. Can So again, I already explained how to get magnitude. Square plus square, square root. Okay, you take this one square plus this one square, square root, you get the magnitude, like what you solved in your vector chapter. Angle. Okay. This is another presentation. Okay, now this curve, where's the center? Over here. So normal pointing this way, tangent this way. Once you have N and T, you can find the resultant. Okay, once you have the AN and AT, you can find the resultant. Same with this one. This curve, where is the center? Over here. Over here. So normal will be pointing inside the curve. So this is a curve, establish T and N axis. Once you find AT, you find AN, you can find the resultant. Then the angle you can find with the tangent relationship. Again, Dr. Ang, how to find AT and AN? This one, AT equal to dV dt. AT equal to dV dt. You'll be given V equal to one equation. You differentiate, then you get AT already. Dr. Ang, how I get AN? AN equal to V square over rho. V square over rho. If you're given VT, you take the VT, square it, divided by the radius. There's one equation later to calculate the radius. If the question do not give you the radius, you need to calculate. One careless mistake is this one. When the question simplified until the particle move in a straight line, when the particle move in a straight line, there is no normal acceleration. You only have AT acceleration. Take note on this one. If you're taking note, put this one many stars. This one, when it comes to exam, you will confuse. You will try to flip, you will try to create one normal here. No normal. If you move along the path, you only have tangent component. Yeah, the question will mention the particle move along the pathway. If the question mentioned that one, particle move along the pathway, you still write these two equations. Normal component 0. Straight away, you write an equals 0, you get 1 mark. If the question mentioned the particle move along the pathway, you write an equals 0, you get 1 mark. Means you understand what is that statement. Okay, you only need to find the AT. Okay, so these are the scenario of the situation. Okay. What happens if you are 3-dimensional? This is 2D. What happens if you have 3D? 3D, same. You put on the gray color is a 2D. 3D only have one plane, B pointing outside. You are using right hand rules. Okay, you are using right hand rules. How you know B is pointing up? You are crossing T to N. It means your right hand rules. Your finger is from T to N. Then it will point up. Okay, let's say this is a paper. Where's the direction? So your T and N always on the paper. So you know where cross where. So for example, this one on here. So put your finger. T cross to N will give you direction of B. T cross to N will give you direction of B. Okay. So direction of B will be used right hand rules. Always T cross N. And in vector, this is vector. Vector is different. If you take N cross T, you get negative. But you only need to remember, always take T cross to N. T cross to N, you get the thumb direction. Thumb is the positive direction. Okay. Then, if N component, how you know the N direction? Same. You take B cross T. B cross T. B cross to T. This direction positive. This is your thumb. You want to show the direction of N. Use your right hand rules. B cross to T. B cross to T. Right? Can you guess UT? Can you guess equation for UT? What cross what? N cross B. N cross to B. Okay. Anyway, this one is for your reading. So this is for your exam times. You can read lah. Read. Okay. This is a procedure. First, again, first step, draw the T and N axis when you have curvature motion. First step is look at the coordinate system, establish T and N on the question paper or on your solution. Second, find the velocity. Find the velocity always tangent to the particles. This one. Always tangent. Draw the V first. Okay, draw the V, and V equal to ds dt. Okay. Then third one only, you go and find acceleration. Acceleration, you only need to remember these two equations. A equal to AT UT AN UN. Then what is AT? AT equal to V dot or dV dt. What is AN? AN equal to V square over rho. V square over rho. Okay, this is a step. Then you only substitute accordingly. Accordingly. The rest you read lah. So you are seeing these three equations. There's only one condition. You can use these three. Which is what? Acceleration must be what? Constant. When you see this one, you can use this one only when acceleration is constant. How you know acceleration is constant? You do all the differentiation at the end, you arrive at one number. Your A equal to one number. If your A equal to 3t, then you cannot use this one. Means your A is changing. Then you cannot use this one. If you arrive, you do differentiation, dv at equal to dv dt. After you differentiate, you get one number, then you can use the 3 Newton equation. If you differentiate, you get 3t something. 3t plus 3, then you cannot use this one. You can substitute value inside there. Okay. This one already mentioned. This one, memorize. No choice. It won't be given. What is this rho? Rho is the radius of the curve, which is this one. You need this equation to solve an equal to v squared over rho. This one you need to memorize. No choice. This one equal to 1 plus dy dx. You do the dy dx square, then bracket exponential 3 over 2, meaning you multiply 3 times. Over 2 means square root. Or you just use the bracket for the exponential component. If you don't know how to do this one, go to the calculator. You calculate inside one, then you press the exponential bracket 3 over 2. You complete the top one, then you do the bottom one. Bottom one, you see, is d2y over dx2. This is double differentiation of the previous one. Okay, how do you apply this one? This one is dy dx. You will be given the curve equation. Y equal to 3x squared plus 4, let's say. To find the curve, to find the radius of this one, you apply that one. What do? You need to do dy dx. Let's say 3x squared plus y equal to 3x squared plus 4. Dy dx, you get 6x. D square y dx square is double differentiation of this one. You get 6. Substitute 6x over here. Substitute 6 over here. Then you multiply in the equation, you see x. Then it will tell you how you apply this x. The question will ask you, when the particle reach at a certain x position, you substitute the x value there. And then you can find this rho already. Let's say this particle move from here, then it give you one position here. It give you maybe 10, 10. So you substitute here, the x equal to 10. Yeah, so this one you need to memorize. So for today's lesson, you actually need to memorize these 2 equations plus the one that on the screen there. 3 equations you need to memorize, and the other is the standard procedure. To solve curvature motion, first establish the T and N. Particle, open your finger, then draw the N and T, n always pointing to the center. T is depend on the motion. If you move from the left to right, then it's this direction. No? Have this one already. Draw the VT component, the particle. T, after you draw the VT, write these two equations. A equal to something plus something. A equal to dv dt or v dot ut plus v square over rho un. Okay. Once you draw this one, once you write this one, if you're lucky, the question will give you the rho. If the question do not give you a rho, you need to call out this equation. This one, if the question do not give you the r, this alone give you 2 marks, 1 to 2 marks. This equation alone. So if you are weak in differentiation, you better work hard a little bit. Okay. Now, when you learn the theory, you need to apply. So let's say you have a skitter. You have a skitter. It reached a point along a parabolic path where you have see the dotted line. Dotted line is the path. Give you y equal to 1 over 2x squared. He landed on an A, had a speed of 6 meters per second, which is increasing at 6 meters over second square. So you should see this one is acceleration. One is velocity. He asks you to determine the direction of his velocity and direction and magnitude of his acceleration at this instance. Ignore the size of the skitter at this moment. Means if you see this question already, don't go and use mg, w in this question. This question do not ask, it asks you ignore the size already. So don't go and involve the F equal to ma kind of equation. Don't go over that direction. This one, you see this question means it's a curvature motion equation already. Oh, okay. So you see this one, it asks you to ignore the size. Size means what? Got mass. Mass can change to what? W. It's a weight. So don't confuse this one with the later chapter. Later, you'll learn about F equal to ma. This one, you see curvature motion, it asks you about acceleration and velocity. Don't mix W or free body diagram in this kind of question. This is chapter one question. Later, you will learn about momentum, work, and all this. Okay. So first steps, you must identify where is your curve. This is your curve. Then, there's a 5 meter there. Sorry, the information missing. Okay, so there are 5 and 10 meter. 5 is a y-axis, x is a 10, x equal to 10. So you have coordinate already. In A, you actually have a 10, 5. Means your x value is 10, y value is 5 at position of A. Okay, now before solving, try to remember what are the steps every time come to the curvature motion. First, establish N and T. Can you draw the N and T axis from the diagram? Do you know how to draw the N and T? Where is the N thing? Inside here? Any lah, as long as this direction. Where is T? This direction. Okay, now put N and T over there. Then what else? Once you have N and T, next step is to know where is your V direction. Where is V direction? Tangent to the curve. So you just follow the T direction. Okay, it's a T direction. This one. You can put VT along this line, no problem. You can put this one, put here, then you write VA or VT also can. Then on your paper, on your solution, you write this one and this one. You write A equal to AT UT plus AN UN. Then expand. What is AT? AT equal to V dot. AN equal to V square over rho. This picture do not give you the R, so it's expected you to use the rho equation just now. So you need to add one more equation, rho equal to something something divided by something. That one. Okay. Then the rest is just substitution. Okay. So there's an angle there. There's an angle there. There's an angle there. So this angle is the tangent and the horizontal axis means your land, your ground. Okay. The T and the ground, there's an angle there. Okay, coordinate system, we already done. Velocity, you already done. Okay. Your diagram should look something like that. There's a curve, N, T, then there's a V, then write VA or VT equal to 6. Right there. Then there's an angle. Later I'll explain why you need angle. Because you need to tell the direction. Direction. So since the R is not given, you need to do differentiation 2 times. Y equal to 1 over 20 x squared. Dy dx equal to 1 over 10 x. Okay, you dy dx, pull the 2 to the front. 1 over 20 become 1 over 10. X remain x. Then you differentiate one more time. Dx square, dy square, dx square become 1 over 10. Okay. So at that particular location, it asks you at that particular location, A, at that instant, at this instant means position A. Position A, you have x direction, f coordinate and y coordinate. In this position, your x, when your x equal to 10, your dy dx is 1. Your tangent equal 1, y tangent equal 1. For the curve, tangent equal to 1. Okay. Or dy dx equal, okay. This is a tangent. Okay. So you know on a curve, on curve, you want to find a straight line like that. On a curve, you want to find gradient on the curve, or you want to find the optimum or maximum point of the curve. You always, in mathematics, you write dy dx equals 0. But in this case, your tan equal 1. It is because your dy dx equal 1. Dy dx actually is dy dx theta. So let me see, how do I explain it? This one you need to refer back to the curve. The curve. But anyway, you just remember tangent. Tangent equal to dy dx. Okay. Mean this is the angle. Right? Dy dx. Okay, this is dy, this is dx to find the angle. Dy dx. In this case, you know that it's 1, so the angle is 45. tangent 45 equal to 1. Okay, tangent 45 equal to 1. So it's 45 degree from the horizon. VA equal to 6. So 45, let me see, 45. Yeah, lah. So it's the same as this way. It's the same as this presentation. 45. This angle actually is the same as another angle here. Yeah. So acceleration, again, recall these three equations. A equal to tangent direct component plus normal component. This one, acceleration in tangent, what do you think? Equal dv dt, what do you get? 0. This is the constant velocity. Constant velocity means no acceleration. Okay, dv dt, you get 0. V, you use back this one. Rho, you calculate. Okay. So yeah. So in this case, although just now we calculate is 0, right? dv dt, this one. But the question already give you 2 meters per second. Okay. The question give you additional direction. Just now, when we arrive at 0, it means we assume there is no changes in velocity. However, this question give you additional information. It give you A equal to 2 meters per second. So you cannot assume this one 0. Okay, so substitute this one as 2. So AT you have, given in the question, AN you need to find. AN equal to V square over rho. Rho, how you find rho? By this equation. So you substitute this 1 over 10 over here. Substitute 1 over 10x over here. Then the square one below. Press calculator. Okay, press calculator. You'll get 28.28. This one you go home, go home and do. Okay. Now again, how you get this answer? By using coordinate of 10 and 5. Your x coordinate is 10, so substitute 10 here. Okay, then at the end you get 28.28. Okay. So you substitute V dot is given to V 6. Rho you calculate 28.28. So you arrive at one equation for A. A equal to 2U plus 1.27 UN meter per second. This one is in vector form. Vector form means you have magnitude direction plus magnitude direction. In the x and y axis, you will see magnitude I plus magnitude J, but this one is curvature. Curvature we use UT and UN. How to find magnitude? Square this one plus square this one square root. How to find angle? Angle is Y and X. Okay. Now this is the angle you want to find, or you can want to find the angle you find. You define yourself. This question I'm using here. You can put here if you want, but label clearly in your diagram. So the rest is just mathematics. So magnitude of A is here. Direction, tangent is 2, and the side, so AN is 1.2, your AT is 2, so tangent is opposite and side. You arrive as 57.5. If you label here, you will find 90 minus this answer. Okay. Okay. Then this 57, right? But the real answer from the horizontal, you get 12.5. There's a knot there. You go home and think how to get 1.25. 12.5. There's an equation here. Go home and think how I get this one. You 45 plus 90 plus 71.5 minus 180. You need to redraw the whole diagram again. Right? So 45, it is here. You draw a line, then draw a horizontal line. So 45 plus 90 plus here plus 90, you get the remaining angle. Right? Or here, you draw a line here. 45 plus 90 plus 75 point something. That's 57.5 something. There's an angle there. There's a remaining angle there. Yeah. So I draw this one. Yes. PN. This is 90 degree. Here to here is 57.5. You want to find this angle. Okay. You want to find this angle. Here is the one that you don't know. Understand, right? Okay. So we stop here. Okay, we stop here. You have a question? Me, yeah? Yes. Wait.